Well, good morning, everybody. Today I'm going to show you guys a little bit about how to graph using the X and Y intercepts. So my notes are going to come from pages 146 and 147. The assignment that goes with this one is page 149 and 150. So graphing using the X and Y intercepts is it's more a matter of convenience. If you can recognize that the numbers work out cleanly for you to use this method, then you can actually graph a line rather quickly. If the numbers don't play nicely, then you may want to use one of our other methods of graphing. But this one's nice to have in our pockets. So since we're using X and Y intercepts, let's start with the definition of both. So the x-intercept is going to be a point where the line intersects the x-axis. For example, we have a graphed line here, and you can see the location where it intersects and crosses the x-axis. One important fact about an x-intercept is that it will have a number and a 0 for its y, because it aligns with 0 on the y-axis here. And so the y-intercept is going to be something very similar. It's going to be the location where the point where the line that we've graphed crosses the y-axis. Now it works similarly to an x-intercept in that all y-intercepts are going to have a 0 for x. So x-intercepts have a 0 for y, y-intercepts have a 0 for x, and we are going to use this fact to graph lines that have numbers that are friendly in this situation. So let's take a look at two quick examples that kind of represent the basic problems that you can use this method on. So the first one is just a basic example from the book. They've given us a line already in slope-intercept form, so y is equal to a 3x plus 6. Now we are going to discover 2 points, the x and the y intercepts. We're going to do this via substitution. So let's start with our x-intercept. An x-intercept is always going to have some number and a 0 for y. So we are going to substitute 0 into this location where we see y, and we will solve for this missing value of x. So I have y is equal to 3. Ooh, sorry. Almost did it wrong on the first one. We're going to put a 0 in for y, so I have 0 is equal to 3x plus 6. This isn't going to be too hard of an equation to solve, so I'm going to go ahead and subtract 6 from both sides. That gives me 3x is equal to a negative 6. And when I solve this, I discover that x is equal to a negative 2. That means that my x-intercept is going to be the coordinate negative 2, 0. Now I just need another point, my y-intercept, and I can graph these 2 points, and I should have this line accurately graphed. So we're going to use the y-intercept facts. Y-intercepts always have a 0 for x. I'm going to substitute a 0 in place of x and then quickly solve this. So go back up to my same equation. Y is equal to 3 times 0 plus 6. That equals y is equal to 6. So my second coordinate is going to be 0 and 6. So I'm going to go ahead and take a second here and just show you what this would look like graphed. We're going to graph most of these. So my coordinates are a negative 2, 0. So a negative 2, 0. And my other coordinate was a 0, 6. So 1, 2, 3, 4, 5, 6. The numbers worked out very cleanly. And now I can just connect those 2 points. And I have this line graphed rather quickly. We're going to use something a little later here called the cover-up method to do this almost entirely mental math. So there's the graph of a y is equal to a 3x plus 6. Let's go ahead and undo that, and let's do another example. So next up, let's take a look at another example, but this one is going to start out in standard form. So they give us x minus y is equal to 2. We're going to do the same thing. We're going to discover the x-intercept and the y-intercept by substituting in zeros in the appropriate location. So first I'm going to go ahead, let's find our x-intercept, substituting a 0 in for y. It gives me x minus 0 is equal to 2, which means x is equal to 2. So my x-intercept is 2, 0. Let's go ahead and do the same thing, but we're going to substitute a 0 in for x to discover my y-intercept. So this is going to be 0 minus y is equal to 2, which means y is equal to a negative 2. So my other coordinate is going to be 0, negative 2, which I can go ahead and graph. So let's do that together. So if I substitute in, I can graph first of all my 2, 0 and 0, negative 2. There's the graph of this line. This one worked out real cleanly, so I would be able to actually find the slope of this line if I wanted to by just counting on the graph. Looks like the slope's going to be 2 over 2, which is 1 over 1. That makes sense. So this is right perfectly on the diagonal. So this can be a very fast method for graphing. I'm just going to knock out a few more examples like this with you. And we just use it. We do the same thing every single time. We just substitute in a 0 for x and a 0 for y and discover the appropriate coordinate that goes with it. Let's look at a couple more examples here from the text. So, and I also want to demonstrate for you the official cover-up method. It works best like example number 5, the next one I'm going to do, if you can just test the numbers real quick mentally, if they work out evenly, then this may be the fastest and best method to graph with. So your job is to find the x and the y-intercepts and graph these lines. So let's do this together. This one is 3x minus 2y equal to 12. Now, in standard form, let's use the cover-up method. So if I want to find my x-intercept, that's the one where I substitute a 0 in for y. If I put a 0 here, negative 2 times 0 is going to be 0. So in a sense, this term goes away. If I cover it up, then I can imagine what it takes to solve for x, which is just a one-step equation. 12 divided by 3 is going to be 4. And so my x-intercept would be 4, 0. Now I'm going to go the other way, and I'm going to substitute a 0 in for x. Let's use the cover-up method. If I put a 0 in here for x, 3 times 0 is 0. So I can just cover this up and solve for y. That's going to be 12 divided by negative 2, which is going to equal a negative 6. So I have 0, negative 6, and with just a little bit of mental math and knowledge about x and y intercepts, because the numbers both divided 12 evenly, this turned out to be a very quick and easy method for us to graph this. So let's graph this line together. My first point was 4, 0. 1, 2, 3, 4, 0. It's my x-intercept. And my other one was 0, negative 6, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And I have very quickly been able to graph this line. Now this method is useful, like I said, the cover-up method is useful if the numbers work out very evenly. In many cases, however, though, you're going to get a fraction or some less usable number that's going to decrease the accuracy of your graph unless you get a little creative, and another method may work better for you to do this with. So there's the graph of 3x minus 2y equal to 12. Let's go ahead and undo this, and let's just do a couple more examples together. Okay. So here we go. Let's go ahead and do number 8. And let's test to see if the cover-up method works. So negative 4x plus 5y equal to 20. Let's find our x-intercept first. That's where we cover up and place a 0 in for y. If I put a 0 in for y, 5 times 0 is 0, so I'll just cover this up. And let's solve this problem for x. 20 divided by negative 4 is going to give me a negative 5. So negative 5, 0 is my x-intercept. And let's put a 0 in for x and see if these numbers work out evenly. Negative 4 times 0 is 0, so let's just cover that up. 20 divided by 5 is going to be 4. So my y-intercept is 0, 4. If we plot these 2 points, we will have a good-looking graph. Let's do it. Negative 5, 0 is going to be negative 1, 2, 3, 4, negative 5, 0. And then my other point was 0, 4, 0, 1, 2, 3, 4. There is the graph of this line. I could use those 2 points to count the slope off the graph if I wanted to. And since I have my y-intercept, if I counted my slope, I could put this in slope-intercept form from the graph pretty quick as well. I think I'm going to do just another one with you guys. Let's see how this works out. Okay, so let's take a look at my last one. Let's do number 10. Now number 10 is an example of one where I'd probably go a different route and graph this using a different method because I should get a fraction. Starts out 2x minus y is equal to 7. Let's use that cover-up method to determine the x and the y intercepts. So let's find our x-intercept first. That means put a 0 in for y. That's minus 0, so let's cover it up. When I divide, I'm going to discover that x is equal to 7 divided by 2. That's 7 divided by 2, 0. And let's see if it works out evenly for the y-intercept. So it's 0 for x, and a y is what we're going to find. If I put a 0 in for x, 2 times 0 is 0. Let's cover that up. 7 divided by negative 1 means that my y value would be negative 7 and 0. So I've got 2 points. Let's see if we can graph this, and we can get a little creative with how we do it. 7 halves. Let's see how that one graphs out. A lot of students have trouble graphing fractions the first time they do it. So let's take a look. I want to go ahead and go half a square. I want to do this 7 times. So that's 2. Oh, wait, we're going to positive 7, 2. So it's 2, 4, 6, 7 halves should be a half square. So there's 7 halves. Now that one may not be accurate enough for us to count the slope using this point, but it is enough to accurately graph the line. Let's go down to negative 7, 0, negative 1, 2, 3, 4, 5, 6, negative 7, 0. And there are our 2 points. This is an accurately graphed line, but if I wanted to count the slope based off of this, I would have to choose different points because of that half. So the theme here, guys, is that you can quickly find 2 points to graph a line using the fact that x and y intercepts both have a 0 as one of the numbers in their coordinate. If the numbers work out evenly, it can be a very convenient way to quickly graph the line. If you do the cover-up method and the numbers don't work out evenly, then I suggest using a different method to graph and solve the equation. There isn't that much to it, so I look forward to working with you in Google Classroom.